Let me take you on a journey to the coldest place on Earth and its last and greatest wilderness, on a voyage to Antarctica. Hello and welcome to A Voyage to Antarctica, brought to you by the UK Antarctic Heritage Trust. I'm Alok Jha. Today we're travelling under the thick Antarctic pack ice to the coldest depths of the Southern Ocean, where weird and wonderful animals are being studied and discovered. These creatures of the frozen seas are teaching us incredible things about our planet's deep past, and even revealing some of the secrets of the universe. Our guest is marine biologist Dr. Hugh Griffiths. He's been working for the British Antarctic Survey for more than 20 years, studying the animals that live at the bottom of the sea around the Antarctic and Arctic. He also studies the potential effects of marine protected areas, climate change, human impacts, and pollution on these unique ecosystems, and has participated in and led multiple expeditions to both poles, studying everything from the beaches to the deep sea. Tell me about the first time that you went to Antarctica. I mean, I don't think you intended to go to the poles, did you? And be in these very cold and dark places. What was that first trip like? What were you doing on it?
So it was way back in 2006. I've been working for British Antarctic Survey for a long time. And it was a 2-month expedition on the then British Antarctic Survey ship, the James Clark Ross, to study seafloor animals around the Antarctic and the chain of islands that lead back up to South America. And it was a trip that left from the Falklands and sailed down. It takes about 5 days to get down to the Antarctic Peninsula from there on a ship. And then we did science all the way back up north with different types of fishing nets and things like that, looking at the animals that lived at the bottom of the sea. And to be honest, it was probably the most exciting thing, and still gives me shivers today just thinking about the amazing stuff I saw on my first trip. You know, the first island we stopped at and got to go ashore at was Deception Island, which is a collapsed volcano which has been flooded by the sea. So it's a bit like going to a Bond villain's lair or something like that. And then we got off the ship, and the first thing I saw on the beach was a penguin, and the next thing I saw was a leopard seal, and then some orcas swam past. And you just think, this is like something from a film or a David Attenborough documentary. So I was really spoilt. And actually, the ship went to most of the places that a lot of tourists pay a lot of money to visit. So I was incredibly lucky for that to be my first expedition.
Tell me about the animals that you saw on that first expedition. I mean, what were you intending to look for? And then what was the sort of diversity of things you ended up seeing? I mean, were you surprised by what you saw?
I was incredibly surprised by what I saw on that first trip, because although Antarctica includes a lot of the same things that you see in the sea off the UK, for example, it's a very different makeup because the water's very cold. So there's some things missing from there, like most types of crabs are missing from Antarctica, even lobsters, and also things like sharks and things are missing from Antarctica. And that means there's a lot of much older, more primitive types of animals that would have been really common around the time of the dinosaurs are still dominant in Antarctica today. So we see giant sea spiders, things called feather stars, which are related to starfish and sea urchins. We have all sorts of creatures that I'd never had a chance to see, even studying marine biology, sort of in the flesh before. And so it was a real wake-up call in terms of how weird and wonderful the creatures in Antarctica are compared to what I'm used to seeing back in the UK.
And I suppose even if there are creatures that are similar to those around the coastlines of where you grew up, given that in Antarctica there is a little less human interference, the diversity and the age of these animals and the kind of differences are going to be quite big, aren't they? And they're kind of frozen in time also as well, in terms of the fact that you've got things there that maybe have changed or died out elsewhere.
Well, it was quite interesting that if you think about somewhere like the Irish Sea, that's dredged or fished 3 times a year on average, every square mile of it is. And so anything that's slow growing or long lived, like corals and sponges and things, tend to be damaged or destroyed very easily. And so what you get are mostly mobile types of animals that can either avoid the nets or escape them. Whereas if you go down to Antarctica, There are some areas that have been heavily fished in the past, but there are lots of areas that have never been fished. And so what you see there are animals that live an incredibly long time. There are some snails that only start reproducing when they're 30 years old there, for example. There are sponges that are estimated to be anything up to 15,000 years old. So it's mind-blowing kind of numbers like that, but also huge things. Like the sea spiders get really big. The biggest sea spider in UK waters is the size of your thumbnail, maybe. But actually, in Antarctica, it's the size of your dinner plate. And you have
don't tell people that before they go to Antarctica. You can't be telling people that sea spiders the size of your dinner plate.
But it's okay, because they live deep in the sea, and they also aren't really spiders.
So tell me about the other trips then. So in the past 15 or so years, you must have been back to Antarctica many times. What sort of areas have you worked in? Are there particular places that you go back to?
A lot of what we do is exploratory science. So going to look in new areas or newly exposed areas, say if an iceberg breaks off and we want to go and have a look what was living underneath that ice shelf and things. So I haven't been back to many places, but every time I go, I get to see something new and exciting. In my 2008 expedition, we were the first people to ever put a fishing net to the seafloor of an entire sea, the Amundsen Sea, which is round by Pine Island Glacier. And that was quite a privilege to be the first people to ever look at what was living at the seafloor there.
So what did you find? I always see pictures and videos of these sorts of expeditions, and there's just an enormous list of completely new creatures that people discover.
Well, on that one in particular, because it was an area that no one had looked in before, somewhere between 10 and 20% of all the creatures we collected were from species that had never been seen before by humans.
That must be so exciting.
It's exciting, but it's also kind of a huge responsibility to make sure that you get those back to the right people. Very often it's quite a destructive technique. If you bring an animal up from the bottom of the sea, it's not going to survive the journey back down. But also you need to physically collect some of these animals to take back to museums so that the experts can have a look at them and really work on if they're a new species or not and describe them. And that can take many years. So making sure you do a good job of that and getting it to the right people is quite a responsibility. But also it's quite amazing then, because we did, on my first expedition, we found so many new species of sea cucumbers that everybody on the expedition got a species named after them. And then 6 months later, the Australians who were doing the identifications for us in the museum came back to us and said, can we use your surnames to name another species after? Because we've got so many new species, you're going to get 2 species each, which is
lucky you.
Quite a crazy thing that if I lived in the UK, finding a new species in my entire lifetime would be one thing, but just within the sea cucumbers in one expedition, we had enough for everybody to have 2 species named after them. So, yeah, it's crazy.
I love the idea of all these new sea cucumbers. Are you going to tell me they're not actually cucumbers, though?
No, sadly they're not, but they are animals. They're related to starfish and sea urchins and things. So that, what we call echinoderms, which means spiny skin. And sea cucumbers do look a bit like a pickled gherkin. And the ones that are named after me are not very pretty, I have to say that. But I love them anyway, because they're obviously my favourites because of that. But actually, it is so rich in Antarctica that we know, and we have named somewhere between 10 and 12,000 species. But we think there may be another 8 to 10,000 species waiting to be discovered. And that's just the big animals that you can see with the naked eye. And in some cases, if you go into the deep sea, it's not 10 or 20% of the animals are new to science. It's 80, 90 or 100% of the animals are new to science just by going a little bit deeper in Antarctica to places where nobody's ever looked.
What are some of the weirdest things you've seen in that part of the world in terms of the creatures?
There are some brilliant Antarctic animals. So there are fish that have no red blood cells because there's so much oxygen in the cold water in Antarctica that they don't need the red blood cells. And the same fish have antifreeze proteins in their blood to stop their blood freezing up because it's so cold. You've got creatures called sea lemons, which are actually...
They're not lemons, are they?
Type of
I'm
snail.
getting a pattern here.
No, they're not lemons. You'll get if it says sea in front of it, then it's not going to be the thing it says it is. But sea lemons are actually snails, which haven't completely lost their shells, but they've got a very thin mother-of-pearl shell inside their body. And they are bright yellow and look like if you were eating a kind of jelly fruit version of a lemon. They're like a big fat version of a jelly fruit lemon.
They sound fantastic.
They're really beautiful things. And then there are just so many other things like these sea spiders I've talked about. My favorite soft coral, which, you think of coral, you think you know what a coral looks like. And then imagine something that looks like an incredibly tall sunflower, but is fleshy, almost like human flesh, pinky purpley colour. And there's a sunflower shape, but at the end of each of the petals, you have little tentacles. So that's trying to catch little particles of food floating. So these things can be a couple of meters tall, and they just kind of sway in the currents and wait for food to float past them. But the first time I ever found one, it came up in a net full of gravel. So as we were digging out the animals from the gravel, there was just this weird thing that looks a bit like something from an alien movie, and it was fleshy. And it just kept going on forever with this long stalk that came off it. And I'd never seen anything like that in my life. And I just thought these sort of things probably did live around the UK coast. And you will probably find similar things in the very deep sea. But in terms of just finding them everywhere, like in Antarctica, it's quite amazing that where you're so far away from human influence and you're losing some of these crushing predators and biting predators, some of the most amazing shapes and sizes of animals can really kind of blow your mind with what you can find.
I'm sure, we can call sea lemons and these fleshy sunflowers, call them weird, but I'm sure that if they were to look at us, they'd think that we were very weird too, to be honest. Now, you have talked about the places that you've been, and you talked about the fact that you're an explorer. But I wonder, do you ever visit or hark back to the explorers of the past? I mean, have you been to any of the historical bases and things, or research places that the British explorers of the past have been to as well, and seen what's there now?
Yeah, so we've been really lucky that in terms of, we passed quite a few historic sites and things on our expeditions anyway. And I've been to places like South Georgia, to the Whaling Museum there, and Shackleton's grave and things like that. And it really brings it home to you what these people went through versus the relative luxury that we have today. We have fairly slow internet, but we have, we can send emails. We could even have a phone call home if we needed to. And the idea that not even the kind of glamorous explorers that we think of, but even the early British Antarctic Survey scientists would be sent away for up to 5 years with a sealed envelope, that once they got to Antarctica, they'd open it and find out what their job was for the next few years and things, and no going home until the job is over. And so for me to be able to sort of almost commute to Antarctica within a season and do all the things I do is quite amazing. The first work in Antarctica on the sorts of things I do was done by the Challenger expedition. And that was sort of 1870s. So well over 100 and something years ago now. And their main aim was to complete an inventory of the world's ocean fauna, which, as you may have guessed, isn't complete.
Has that happened? Has that finished? No.
Yeah, exactly. And it's just this thing of we're still adding new species. We're still, new sea cucumbers all over the place. And it's that thing of actually what I do isn't new. As much as I like to think, oh my God, I'm doing these amazing cutting edge things and I'm finding new things. We have new tools. So things like genetics and things really help to speed up identifying animals and things like that. And we have brilliant video technology and miniature submarines that we can send down to collect samples for us and things. But essentially, we're doing the same job of going to places that may or may not contain new forms of life that we've never seen before and trying to work it out and piece it together. And sometimes it's a real mystery and it can take years to find out what it is. Other times there's a person on the ship who goes, oh, I've seen 10 of them before. And you're like, really? So it's a real mix of stuff that we're familiar with. And even the animals that are new to science, some of them look familiar, like starfish or sea snails and things, are really things that don't look that surprising. You're used to them on the beach in the UK, for example. But then there are these other creatures which really are nothing like anything you've seen before. And you get to go to places that are nothing like you've ever seen before.
You mentioned Challenger, the ship that sort of started the science that you do, which is to sort of try and catalogue the creatures in the ocean, essentially, to try and understand what was out there. Before then, of course, people used to ignore the oceans pretty much in terms of life. People assumed that there wasn't much life below a certain depth in the oceans, I believe, which was shown to be clearly wrong. And that challenge that the Challenger started is still going on, as you say. And I wonder, where did the sort of discipline in marine biology start? Was it with that expedition, or were there already people before then surveying oceans and surveying seas and trying to work out what was in the water?
Well, I think for the stuff that's close to shore, there were lots of kind of right back to the earliest cataloguing of life when people started to give Latin names, Linnaeus and people like that. Anything close to the shore would get a name. But it's still amazing how many species didn't get a kind of official name. And that's because a lot of the time with sea creatures, we can't be there. So we might get a few minutes video, or we might have a scuba diver go in and have a look, but you don't observe all their behaviors and who's eating who and who's breeding with who and all of those kind of things. So the complexity of life under the ocean, especially on the seafloor, where we're not necessarily eating too many of those species, so we're not historically haven't been that interested in them. There are these thousands of species that I'm talking about that actually about 50% of them have only ever been found once, because the level of work that needs to be done to even understand where they live normally and what they eat and how old they get and all of these kind of questions for most species still aren't known. So although that makes it sound like we've done a terrible job as marine biologists, if you think that Antarctica is bigger than Australia or bigger than Europe almost, if you think of how many people go there every year and how many of those are actually looking at the bottom of the sea, it's quite understandable that an entire continent with only a few ships looking each year at these kind of things, you're never going to get the complete picture. At the moment, we could lose species in Antarctica with climate change and not even know they ever existed.
I was quite struck by what you said about how sometimes these species that exist in the books now have only come from evidence of one sample, essentially. And so how on earth do you understand its population or its life cycle or how it's being affected by environmental change? There aren't enough data points to be able to do those sorts of things, I guess, are there? But the stuff you do find out is fascinating. Let me take you back to March 2022. That's when Shackleton's ship, Endurance, which, by the way, had sunk more than 100 years before, it was found at the bottom of the Weddell Sea. And you did a really interesting sort of marine biology take on it. Everyone was excited about the fact that the ship had been found and it was in quite an amazing condition, actually. And there were loads of these amazing pictures and videos of it. But your Twitter thread was all about the animals you could spot. And you were so excited by all the different things that you saw. Tell us about a few of them.
Well, it was quite an interesting experience because they released 30 seconds of video online, and it wasn't even the highest resolution in the original sort of press release bit. And for me, it was just amazing. The ship looked like it sank yesterday.
I was going to say, the ship was in such great condition. You could even see the writing. Then that's how you knew it was the Endurance.
Yeah, and the wood was in perfect condition. And that is something you just don't get in the rest of the world. And that is, again, part of Antarctica's uniqueness. Antarctica is surrounded by these huge currents. There's something called the Antarctic Circumpolar Current. And it keeps the warm water out and the cold water in general. And it also seals off Antarctica in terms of being a place that has no trees. There's no natural wood or trees in Antarctica. So the rest of the world, even in the Arctic, wood and trees and things tend to wash up on the beaches. Even the north coast of Iceland has got sawmills, even though it has no trees, because the amount of timber that washes up from Russia and places on Icelandic beaches. But Antarctica doesn't have that. So certain types of mollusks and worms and even bacteria that eat wood are missing from Antarctica because there's just no natural wood supply for them to live off. So if a wooden ship sinks in Antarctica, it'll survive longer than a metal ship.
That's fascinating.
Because it's not going to decompose. There's nothing there to eat it. So the timber on the Endurance is pretty much perfect. You can still see varnish on parts of it. So that sank. And it landed at the bottom of the sea, pretty much upright and perfect. The only damage to it is what happened when it was crushed by the ice. So we know when that sank. Thankfully, nobody died. It's one of those rare shipwrecks where you don't have to feel guilty enjoying the beauty of it. But at the same time as everybody was impressed by the amazing structure of the ship, what I was looking at as a marine biologist was what's living on the ship. And it had everything from soft corals, giant sea squirts, a special type of starfish, which filter feeds. And almost all of the animals that were on the ship were filter feeders. They're the sorts of creatures that are like sponges and corals and things that actually catch tiny particles of food that are floating past them in the waters. And I'm not a taxonomist, so I'm not one of those people who gives names to new species. I find them, find the right people to identify them, and then I do my science using the IDs that they give me. So what I tried to do with my Twitter feed that day was to get all of the people from around the world who I thought might be listening or watching, who I knew could help to identify these creatures, and I could have tagged them in it. So it started off as something just for, I don't want to use the word geeks, but it was for enthusiasts, to put it that way. But it quickly captured the imagination of general public, because they were also looking at this ship going, wow, that's beautiful, but what's the weird thing growing on it? And to have a bunch of experts from around the world having a discussion live on Twitter about, oh, do you think it's one of these? And there was one thing that we still don't know what it was. The coral people think it's not a coral, and the other groups of animals that the coral people thought it were, those experts are saying, no, it's definitely a coral. And this debate is great because we've only got 30 seconds of video and we're suddenly having debates about what things are. And then when they released a slightly longer clip of a minute, we saw what looked like a small crab, a small white crab. And that doesn't sound too crazy a thing to see in the sea. But if you imagine that in 150 years of exploration of the Weddell Sea, nobody's ever seen anything that looks like a crab before, because the water in Antarctica is pretty much too cold for most types of crab. And it turns out to be, we think it's probably a type of squat lobster. And in some places, relatives or animals from the same group will eat ship's timbers. So it could be that crab wasn't eating the filter feeding animals, but it might have been there to actually eat the ship, but very slowly, I guess.
Some of the creatures you saw, you had anemones, you had sea squirts, all sorts of, almost like, well, from the pictures, they look like sort of glowing aliens that are sort of floating around. My favorite was the sea anemone on the bow of the bridge, which you gave a Titanic treatment to. I mean, I don't know if it was really doing that, but let's hope it was. It was on the bow of the ship, sort of looking out onto the sort of scene ahead just before the ship sank, maybe. But what's interesting about that is that you had, a minute of video, but you managed to do quite a lot of science with it. I mean, it's quite incredible that you can do that.
It is, but also we're really looking forward to, and it may not be me, it may not be any of the people who had that discussion. There will be scientists who get to look at the full range of data that they collected, and they did a lot more work than that 1 minute of video. And they have 3D scans of the ship, which will include the animals. So we'll be able to know the size of those animals exactly and things like that. So real science can be done, because actually, just like with the Titanic, for example, we know when that sunk, and they've seen that sometimes corals will grow in one place and by next time they visit, they've died. So that means those corals are probably growing quite quickly, and then there's another one popped up somewhere else. Whereas on the Endurance, we've only seen it once, but it had quite a lot of life, but it was not everywhere on the ship. So it seems to be in places where there are good currents coming past, maybe where they can get a better foothold and hold on tight, because the ship isn't covered in sediment either, which probably means that there's decent currents flowing past it that keep it quite clean, which is great if you're a filter feeding animal, but also means there are probably places where the currents aren't favourable for larvae settling on the ship and things. But if you think that this ship has landed at 3 kilometres down, which is incredibly deep, and the normal Antarctic environment at 3 kilometres down is very soft mud. It's incredibly soft, oozy kind of mud that is everywhere. Thousands and thousands of kilometres of soft mud with the occasional rock that sticks out, or what we call drop stones, which are brilliant. They're rocks that were swept off the land on the underside of glaciers. And when those glaciers reach the sea and become icebergs, they're stuck to the bottom of the iceberg until it melts out and drops to the bottom of the sea. And they can be dropped anywhere. But these are like little islands of hard substrate, so a hard place to grow on. And those solid substrates then are quite rare. And they're definitely not normally as big as the Endurance. So the Endurance represents this weird oasis for all these animals that require something hard to grow on. So in a sea of soft mud, you've got this island that is the Endurance.
Hello, I'm Camilla Nichol, Chief Executive of the UK Antarctic Heritage Trust. We work to preserve and protect Antarctica's unique heritage, from the historic huts of early pioneers to the amazing discoveries in climate science. Our mission is to inspire current and future generations to discover, value and protect this precious wilderness. Every year, our specialist conservation teams head south to Antarctica to conserve and protect our historic huts. With your generosity, we can preserve these amazing sites and bring to life the many fascinating stories they have to tell. Find out how you can help save Antarctica, protect our planet, and even adopt a penguin at ukaht.org, or search for the UK Antarctic Heritage Trust. Thank you. Enjoy the rest of the show.
Antarctica, the coldest, driest, and windiest place on Earth, where the penguins outnumber the people, there are only 2 seasons and no time zones. Discover this vast, breathtaking, frozen continent on a Hurtigruten Expeditions cruise. It's an adventure like no other. Explore the landscape, get closer to nature, and learn more than you'd expect with our knowledgeable Hurtigruten Expeditions team. Search Follow Your Curiosity to book now.
You mentioned a little bit earlier about the technology that you can use now compared to some of the earliest pioneers of marine biology. They would have wooden ships and they would go around trying to sort of sample the water and see what's in there and all of that. But you've got robotic instruments, you can use satellite data, all sorts. Just take us through the sort of the cutting edge of how people like you are monitoring the oceans and trying to understand what's living in them. What are the sort of most interesting bits of technology and where is it going? What have you got coming along down the pipe that's going to make it even better?
So we have everything from stuff that's in outer space, like satellites that are helping us monitor things like sea ice, glaciers, but also things like algal blooms. So the sea turns green and you can actually detect that with satellites from all of the microscopic plants and things growing. And to see where these hotspots in food are and things are very important if you're going to try and understand why things live where they do and why they don't live in other places, for example. But when you're actually looking at the bottom of the sea, once you go sort of more than 100 meters deep, the satellites and things aren't that useful to you in terms of monitoring life. So then we need to find ways of reaching them. So a lot of the times when you're going into very icy areas and stuff, sending 50 or 100,000 pounds worth of equipment under the ice and hoping it comes back could be foolhardy. But there are some oceanographers who attach the same sensors to elephant seals, for example. So these animals are hunting for food in places under ice and things where we wouldn't necessarily be comfortable with the technology we have at the moment in sending it there. And they also naturally track things. So we also have devices on penguins, and penguins are incredibly good at finding what we call fronts. So fronts are the areas where the ocean changes. So you might have 2 currents meeting or 2 water bodies meeting, and there might be a warm one meeting a cold one. And that's very often a place where there's upwelling of food and nutrients. And so penguins can find these things much better than humans, ships or robots can. And then you can send your other robots to that area and things. So there's working with nature, but also not doing anything that would stop the animal from being able to live its normal life, because that's also incredibly important. You don't want to be harming the animals who are working with the oceanographers. But it's amazing to use the kind of natural skills of the organisms to help us find things we would never be able to find on our own.
I wonder, one of my other interests is to work out and understand if there's life elsewhere beyond the Earth, right? I'm really interested in this question. And I know that there is an overlap between some of the work that people like you do and the astrobiologists who try and look for environments in other places where there might be life. I wonder, how much is the work that you're doing, sort of trying to map our own planet, is that going to be useful to the astronomers and things who are looking on moons like Enceladus, where there are oceans as well, where they're trying to look for anything that might exist down there? Because we're finding life in so many strange places that you would not normally expect.
I'm very interested in it, and it actually has all sorts of implications back to even the earliest life on Earth. The fossil record dates back to 500 odd million years ago with the first animal fossils. But that doesn't mean that was when the first animals arrived. And there is genetic evidence from what they call molecular clocks, which is kind of trying to date back all the different mutations in the genome and things, that actually suggests that animal life potentially arose 700 million years ago, which would mean animal life would have survived 2 snowball Earths and 1 slushball Earth, which, if you imagine the entire planet caked in ice, a kilometre thick, all the oceans sort of being trapped in a similar way to what I described for parts of Antarctica, it's a brilliant analogue for, well, if life can survive under these ice shelves in Antarctica, and we have found it in many places with these very small, brief glimpses we found life under these ice shelves. So it means if life did arise earlier, as some of this molecular evidence suggests, then why couldn't it have been living like some of the modern day Antarctic animals live? And that's a really fascinating thing. And then if you can translate that into space, where you might have an entire moon covered in ice kilometers thick, it doesn't mean that there's no way for these things to survive there either. And in fact, one of the things that we have in Antarctica is something called a diversity pump, which is that the ice coming and going and these harsh conditions putting pressure on different forms of life pushes them to evolve. It's almost like an arms race of surviving the ice. So you become more complex or you develop new ways of surviving that drive evolution maybe a bit faster than it would have been or cause a bit more complexity in life. And so it's really interesting, the idea that people keep thinking about Antarctica in terms of it's a very harsh place to live. Whereas actually, if you have adapted to living there, it's a brilliant place to live. The temperature is fairly constant, even if it's not very hospitable to most types of life on the Earth. If you're adapted there, it doesn't change too much. You've got high levels of oxygen. You've got all sorts of other things that are useful to life. And, if a sponge can live 15,000 years, that shows that there's something good about being able to live in Antarctica in terms of long-term prospects. And so why can't there be some very slow, long-lived animals living in other parts of the universe in similar ways to the way they do in Antarctica today?
Just two final questions for you before we go. If you could take just one object with you to Antarctica, what would it be?
Oh, that's really hard. But one of the things I do take with me every time I go is a pad of nice drawing paper and a drawing pen. I enjoy drawing, but I never give myself an opportunity in what I'd call the kind of real world back here in Cambridge to spend time working on something like a drawing or a painting or something. But when you're on a ship, having something like drawing where you can really just focus on something and it's quite therapeutic, it's almost like mindfulness or something like that. And I know some other people who build little balsa wood models of things, other people who might take a musical instrument with them and find themselves a nice quiet place to go and play a musical instrument. It's those little bits of something that you're doing just for yourself in a world that's kind of otherwise 24 hours a day work is incredibly useful. So it's something I already take with me, but it's something I really treasure when I'm there.
And the final question to you, why does Antarctica matter to you?
I could give you the kind of science or climate change answer of because it's such an important natural laboratory or it shows us how the world is changing and things. But actually, it's spectacular. It's blown my mind in so many different ways on so many different times. And it seems quite shallow to be impressed by the visual aspects of Antarctica, but it's everything from the sights, the smells or lack of smells, the feeling, the temperatures, everything's so extreme and so beautiful that even in the biggest storm or whatever, there's something spectacular. And just the experiences of being, followed by whales or seeing emperor penguins waddling along the ice or all these sorts of things like living in a David Attenborough program is something that it will always be with me. And I always know I'm privileged to go to Antarctica. And every time I go, I feel like almost like a little kid excited to go and get super excited when I see my first iceberg or whatever. But it is just too much to try and express in one sentence, I guess. But Antarctica is so big and so beautiful that it couldn't not matter to me, if that makes sense. And this is from a person who didn't want to go there when I was 21, who had no intention of ever working in Antarctica because it was cold. But once you see what it's really like and you get past some of the stereotypes, there's nowhere else like it on the planet.
Hugh, thank you very much for your time.
Thank you very much.
Thank you very much for listening. A Voyage to Antarctica is brought to you by the UK Antarctic Heritage Trust and made possible by support from Hurtigruten Expeditions. To find out more about our guests and find out how you can support the Trust, please head to our website, www.ukaht.org, or to our Facebook, Twitter, and Instagram pages. If you enjoyed this episode, please don't forget to follow and rate us wherever you get your podcasts. It makes a huge difference to us. Next time, I'll be talking to explorer Sophie Montagne from the British Army's Ice Maiden team, which in 2018 became the first all-female team to cross Antarctica using muscle power alone. This podcast is part of the Trust's Antarctica in Sight programme, supported by the Foreign Commonwealth and Development Office and charitable gifts and donations. A Voyage to Antarctica was presented by me, Alok Jha. Music is by Alec Hughes and editing by James Stickland. The show is produced by Jessica Norman. See you next time.